Hey guys, Mr. Jenkins here with your video for section 2.4, which is about solving equations that have variables on both sides. Just so you know, this is about the midpoint of the chapter, and we've covered some pretty important stuff up to this point. So we will have some sort of a quiz next week over all the solving equation stuff. So with that said, we'll go ahead and get to it. Our learning targets are we want to be able to solve equations with variables on both sides, and we want to identify equations that are identities, or I call that infinitely many solutions, or have no solution. Okay, so we kind of get into that stuff a little bit here too. All right, so we will get right to it and jump into the examples. Let my computer get caught up here. There we go. All right, so looking at 1a, it says 5a plus 2 equals 2a plus 14. All right, so what we want to do here is, and I'll actually write this out. Sorry, I got a little bit ahead of myself. Here's kind of a checklist you can use to solve, right? So you want to, if necessary, simplify both sides. We won't have to do that step much, if any, in this lesson. And then step 2, we'll have to do a lot of this. Get variables to one side. Let's just say get like terms to same side. And then you want to, just basically solve. And you want to divide by your coefficient. I don't know if it's 2 F's or 1. We're gonna go with 1. Coefficient. Almost positive I spelled that wrong, but you guys will correct me if I did. All right, so 1a. So don't need to simplify either side, no like terms on either side, no distributive property. So we're ready to go to step 2, which is get like terms to the same side, right? So I can either choose to move 5a over there or 2a over there. Now you're always going to see me choose the smaller coefficient. If I move the smaller coefficient, then my coefficient will always be positive, okay? So I'm going to choose to move this term over to this side, okay? But I can't just move something, right? I got to use algebra. So how can I do that? I am actually just going to subtract 2a from both sides. Because what's 2a minus 2a? That's 0, and that's what we wanted. Okay? So after that, I end up with 3a plus 2 equals 14. 0 plus 14 is 14. And then you've got just a simple two-step equation, right? So I'm not going to show much work after this. I'm just going to subtract 2 from both sides, and that's going to give me 3a plus 0, which is 3a on the left side, and 14 minus 2, which is 12 on the right side. And then we're ready to go ahead and divide both sides by the coefficient, which is 3. So we get a equals 12 over 3, which is 4. Okay. So just to kind of recap, we moved our variables to the left side, and then we moved our constants to the right side by doing minus 2 to both sides. And then we just divided both sides by the coefficient, okay? So I'll skip maybe B and C and do one more. Let's do D. Okay, that looks maybe a little bit tougher. All right, so again, I want to try to move my smaller coefficient, so I'm going to choose to move negative 3d over there, okay? So I'm going to add 3d this time. You always do the opposite. On the left side, it gives me 0 minus 5, which is negative 5. On the right side, it gives me 3d plus 3d is 6d. And we still have that plus 11 over there, okay? Then we want to move the plus 11 over to that side. How do we undo plus 11? That's minus 11. So minus 11 to both sides. On this side, be careful here. I'm going to punch this in. Negative 5 minus 11 is negative 16. So we get negative 16 equals 6D. And so then we just divide. Negative 16 divided by 6. Ooh, that's an ugly one. We know, hopefully we know at this point MathXL will not accept that. So on your TI-30, you would use fraction to decimal. Unfortunately, I don't have a TI-30 to show you that with. So I have to use that function, this function on my calculator. But that'll turn it into negative 8/3. Your calculator would probably say negative 2 2/3, okay? MathXL should take either one. All right, so either way. All right, now the dreaded word problem. Let me make this a little bit smaller so it fits on the screen. It says an office manager spent $650 on a new energy-saving copier that will reduce the monthly electric bill from $112 to $88. So that's per month. And how many months will the copier pay for itself? All right. Another way to ask this question is, when will we break even on our investment? Okay. So what we want to basically do here is, well, we can always define our variable. So it says in how many months. So we'll let M equal number of months. That always helps. And then we're going to write an expression for cost for the new one and for the old one. All right. So for the new one, it's going to be $650 is what we spent up front. And then the monthly cost is $88, right? So my total cost for M months for the new guy is 88M plus 650. You always got to include that startup cost, that one-time fee. So that's the new. All right, they don't give us a startup cost for the old one, so we are just going to go with the monthly cost, right? So the monthly cost for that one is $112 per month. So 112M. And then we set them equal to see when we draw even, which kind of makes sense, right? So we want to get like terms to the same side, right? So in this case, that means moving 88M over to that side. So minus 88M, both sides. Gives me just 650 by itself on the left side. And then whatever 112M minus 88M is, make sure I don't mess up. So that'd be 24M. Another 24 appearance. Yeah. All right, and then at that point, we can go ahead and divide. That was 650 divided by 24. Gives me 27 and change. All right, so that's 27 point. About 27.1, we'll call it. All right, and then we want to put that in context, right? So obviously we're not going to pay 0.1 months of a bill, right? So we would say that, you know, we're going to start saving money on the 28th month, right? So say after 28 months. 27 months gets us close, but after 28 months, we are officially saving money at that point, okay? Which is always a good thing. All right, so moving into some other examples. Solving an equation with grouping symbols, right? So this gets to the part where I have to simplify one or both sides, and then I go from there, okay? So looking at A, we need to distribute on both sides. So 2 times 5A is 10A. 2 times minus 1 is minus 2. Then you got 3 times A is 3A. 3 times plus 11 is plus 33. Let's see, I don't know if that's going to pop up or not. Give it a second. There it is. All right, and then now we're ready to just solve. Now it's basically like an example 1 example, okay? So my smaller coefficient in this case is 3. So I'm going to move the 3A. So minus 3A to both sides is going to give me 10 minus 3 is 7, so 7A minus 2 equals 0 plus 33 is 33. Then you just have a simple, 2-step equation, okay? So moving this term over there, that's plus 2 to both sides. And we have 7A equals, that'd be 35. And then unfortunately, I'm kind of out of room, but I'll just skip C. So when I divide both sides by 7, I get A equals 35 over 7, which just simplifies to 5. Okay, maybe do one more of these. Let's just do B. Yeah, do B. It's got some negative stuff in there. All right, so start out by distributing. 7 times 4, 28. 7 times negative 1b or minus 1b is minus 7b. 3 times b is 3b. 3 times minus 4 is minus 12. Hopefully I didn't write all over everything. It's kind of hard when it's invisible. All right, so that works. So now in this case, which coefficient is smaller? Negative 7 or positive 3, that'd be negative 7, so I'm going to move this one. So how do I undo minus 7b? I do plus 7b to both sides. On the left side, that's going to give me 28 plus 0, so just 28. On the right side, 3b plus 7b is 10b. And then I have the minus 12. Then I want to move the minus 12 from the right to the left. That'd be plus 12 to both sides. On the left side, 28 plus 12 is 40. On the right side, I have 10b plus 0, so just 10b. And then all we need to do is divide. So b equals 40 over 10. It's the same as b equals 4. Okay, and then again, I think this is so important. I know I tend to gloss over it at times, but it's always nice to be able to go back and just double check your answer, which you can always do with an equation. Okay, it's not always easy depending on how tough the equation is, but I'm going to just show you an example of that. So if I want to check my solution, I'm going to do just like I see it, 7 parentheses, 4 minus, and then I'm going to sub b for 4. Sorry, 4 for b. And I'm going to see what I get. Okay, so when I plug it in on that side, I get 0, which makes sense. And just so I remember that, I'm going to actually write out. I'm going to actually write out 0. Okay, because you kind of have to sub it in twice here. So I got 0 over there, and then I'm going to try one more time, right? So 3 parentheses. Instead of b, we're going to do 4 minus 4, so we're looking good. That's going to be 0, 2. Then we know we have it, right? If we get both sides to match, we did our job, okay? All right, so the last one, looking at some no solution and IMS stuff. So remember, no solution basically means there's nothing I can sub in for my variable to balance the equation. IMS means anything that I sub in for my variable or satisfies the equation. Okay, so here we go. Looking at A, got 10A plus 12. Just going to copy that. Equals, and then we'll distribute. 2 times 5A is 10A. 2 times plus 6 is plus 12. All right, now we can't decide which one's the smaller coefficient because they're both the same, right? So that's going to be a red flag. If you have the exact same coefficient on opposite sides, it's always going to be either IMS or no solution. So that's a good thing to remember, because watch what happens, right? So when I subtract 10A to move either one, it cancels them both out, okay? And then at that point, I'm left with whatever I'm left with. On the left side, 0 plus 12 is 12. On the right side, 0 plus 12 is 12, right? So now I'm just going to evaluate. Is that true or false? Clearly, we know 12 equals 12. So that is an IMS. Or on MathXL, it might say always true or identity. So there's lots of ways you can say that. Okay, so I like IMS for infinitely many solutions, but MathXL might be looking for one of these two. All right, so just to recap, IMS, or always true, has the exact same coefficient and the exact same constant when simplified. All right, so let's look at the next one. So 9b minus 4 is already simplified. The other side is not simplified because I have like terms, right? So I need to combine like terms. Negative 3b plus 12b is 9b. And then plus 5 is just plus 5. All right, so at this point, again, 9b on opposite sides, those are going to cancel each other out. And this time what I'm left with is 0 minus 4 is negative 4. And 0 plus 5 is 5. So if the numbers don't match up exactly, that's called an inequality, right? And there's no variables to balance it out. So that means this one cannot be solved. So this is a no solution. All right, I'll leave the other two for you to try. But just to summarize, IMS has same coefficient, which is the number attached to the variable, and the same constant. A no solution has the same coefficient, but a different constant. So lots of similarities, and remember your red flag is if I have 2x on the left side and 2x on the right side, I know it's going to be one of the two, either no solution or infinitely many solutions. All right, so that's your lesson. You can see the rest of the examples that I skipped on the filled out notes. You can ask about them in class, but I suggest, try a few on your own. Make sure you get it. And that will conclude our lesson for 2-4.